So now that we have all of our vocabulary defined, let's put it to practice. This first graph looks like we have a V graph. So we have to fill out all of these information right here. First, we have to find the x-intercepts. There are two x-intercepts. One is over here at 3, 0, and one of it is at negative 3, 0. And yes, guys, make sure you write it as a point. And it's negative 3, 0, and 3, 0. Remember, x-intercept is where the graph crosses or touches the x-axis. Y-intercept, we happen to have one as well. That's at the vertex, and that's 0, negative 3. Remember, y-intercept is when x equals to 0. So 0, negative 3. The domain is talking about what all of the x values that we can possibly have. And as you can see, it keeps going to the right forever and keeps going to the left forever. Oh, by the way, in decimals, as we teachers use decimals to graph out the functions, if you don't see any close dots in the ends here, I mean they do go on forever. Whenever you guys see the dots in the end, like that, okay, that means they do not go on forever. So if it's open or closed dots, I mean they do not go on forever. If you don't ever see the dots, then that means they do go on forever. So the domain means all real numbers. Also, we could write this as an interval notation. All real numbers meaning that it can start from a negative infinity over here because this graph goes to the left indefinitely, and it ends at somewhere which we don't know because the arrows mean they go right indefinitely. So when we write the domain, we write negative infinity to infinity if we choose to write it as an interval notation. And yes, we're gonna practice interval notation as well. The range is talking about all y values, okay? So what is the smallest y value that we see? It's right here. The smallest y value is at negative 3, and it goes upward. Oops. So back in the days, we say, okay, y is really bigger than or equal to negative 3. And the reason it equals is because it is on negative 3. Now, interval notation, because the arrows go upward, meaning that at some point, we don't know when, it's just going to hit 1 million, 10 million, 100 million. So in interval notation, we write a bracket, and I will explain the bracket in a little bit, from negative 3 to positive infinity, meaning that, okay, at some point, it's going to keep on going and going and going forever. You can't stop it, right? So if someone said, well, what if it stops at 10 million? No, it doesn't. Okay, it can go up to 100 million. Now the bracket, this bracket means it's inclusive. That means it can be negative 3 versus the parentheses. The parentheses mean it cannot include it. Okay, it's non-inclusive, meaning that it won't be. So if you have negative 3 to infinity, meaning that this graph does not touch, okay, the graph doesn't touch negative 3, which is false in this case. In this case, the graph does touch negative 3 on the y value. So the bracket means inclusive, and the parentheses mean non-inclusive when we're using interval notations. Now, why do we always use parentheses on the infinity? Well, because we don't know what infinity is, right? That's why we can't include infinity. Your large number could be 1 million, but I could be 1,000,001, and someone else could be 5 million. So that's why the infinity numbers will use parentheses all the time. Vertex or inflection point. For this particular case, it is definitely going to be a vertex, and the vertex is at 0, negative 3. Is it a maximum or minimum? This is definitely a minimum, and the minimum is where the vertex is at. Now, end behavior. This is a new concept to us. Remember, we talked about end behavior is what is the behavior of y as x is going towards negative infinity. And negative infinity is all the way over here. So as x is going towards negative infinity, y is going up. So that means y is approaching positive infinity. Similarly to, hey, where is y? What's happening to y as x is going towards positive infinity? If x is going towards positive infinity, y is going up as well. And yes, both y's could be positive and both y could be negative. Increasing and decreasing interval. So let's find the vertices and break that up. The vertice, currently, it's at x equals to 0. Okay. Now, we don't have any other vertices, so we're going to use intervals of negative infinity and then positive infinity. So the first one we're going to write is negative infinity to 0. The second interval is 0 to infinity. Now, mind you, increase and decrease, we have to use x values, and we have to write the x values from small, comma, big. So earlier we talked about increase and decrease. Decrease meaning that can you slide down on the curve? And this one you can. Whee, whee, right? So this side, it's decreasing, decreasing. Now on the right side, oh, you're huffing and you're puffing because you have to hike this track. So this side is increasing, okay? So increasing interval is from 0 to infinity. Decreasing interval is negative infinity to 0. And no, it's either increasing or decreasing, or maybe later constant, but they can't be the same. A function can't increase and decrease over the same interval. Next piece, is this a function? Okay, remember we talked about a function meaning that only one x, right? One x maps one y, so, or passes the vertical line test. So if I draw infinitely many vertical line tests, it's the x value, in this case, touching or more than one time. In this case, whatever x I draw is only once. So this is a function. So this is yes. Is it a one-to-one function? So a one-to-one function proves that it has to be a function first. After you prove that's a function, now every y value can only have one x. Uh-oh. Okay, that's a problem because here's y number 1, y1. I got this dude over here, that's x number 1, and this dude over here is x number 2. So this one y value has 2 x's. And as you can see, that horizontal line intersects twice, meaning it did not pass. So this is not a one-to-one. Evaluate f of 2. F of 2 meaning that when x is 2, what is y? So I'm going to find 2 on x and draw a line. Beep, 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 beep. So there's x equals to 2. Okay. Now y is right there. It intersects y right there. And right there means the y value is at x. So this right here, it's 1. So f of 2 equals 1. If I can get my pen to work.